Okay, recording now. This is a review on algebraic expressions or relations when you are coming up with an algebraic expression or relation from a table of values. Before watching the recording, please make sure that you have a graph sheet of paper with you. Jot down today's date at the top of the page, and then your title is 3.2 review. You do not have to copy the picture here with the stars and the figures. This is just a reference for us to write our first t-table. I would like you to jot down, though, the definition of an algebraic expression or relation, because that's what we've been dealing with for the past few lessons. So in this context, an algebraic expression or relation is used to describe a pattern from a table of values. Okay, so we're one step up from last year where we would simply just have a pattern rule, but we didn't really formalize it into an algebraic expression consistently. So now we're only going to be using algebraic expressions or relations when we describe a pattern from a table of values. So please pause the recording and jot down again the date, the title, and the definition, and then we'll continue. Okay, I'm going to move forward. So going back to the picture of the stars up here, so you'll notice that you have three different figures or terms. When you're setting up a table of values based on pictures or figures, they're often referred to as figures or terms. So you have figure 1 there, figure 2 here, and figure 3. So again, they could be called terms as well. And that will make up our input. So please copy down this t-table here. So we're going to create a t-table or a table of values based on the picture of stars. So I'm going to call this input. So, and then you should know that the right side of the t-table is going to be output. Now, typically we would have X and Y, but we're going to use the context of the stars here and call this our term number or figure number. And then the output is going to be the number of objects. So in this case, it's going to be stars. Okay. So the figure number in this case, we're also going to give it a variable and we're going to call it n. Okay. We're going to use n as our figure number. So, and I'll just highlight that as well. Number of objects. Okay. So we know that we're going to give the numbers that are already listed here, okay, as our figure number. Okay, we're taking that from figure 1, figure 2, figure 3. So you can do the same thing on your chart. So our input will be figure number 1, figure number 2, and figure number 3. I'm also going to write down figure number 4, 2, because you should be able to predict how many objects there are in figure number 4 once we've determined a pattern. So all you have to do now is count the number of stars in each figure number and jot down the corresponding output number. So for example, if we know in figure 1, we have 1, 2, 3 stars, our output for figure number 1 will be 3. So do the same for the others, and you can pause it and then just to check to see if you're on the right track, or you can do this with me. In figure number 2, we have 1, 2, 3, 4, 5 stars or objects. In figure number 3, where we have 1, 2, 3, 4, 5, 6, 7. So you may notice a pattern already. So jot down what you think will be the number of objects or the output in figure number 4. So I'm going to predict it seems to be going up by a pattern of 2 or increasing by 2 on the output. So I think it's going to be 9. Okay, now this is going back to earlier this year or back in grade 6 when we were dealing with pattern rules. So we are still going to deal with the pattern rule, but like I said, we're going to change it at the end into the algebraic expression or relation. So what that does is that you want to describe what are you doing to the input to get to the output, okay? So remember, pattern rules can be 1-step or 2-step, okay? So I'm already looking at this and I can tell this is probably going to be 2-step. You will run into pattern rules that are still 1-step, but generally expect a 2-step pattern rule from now on. Now, this also applies things that we've been talking about and learning previously in this unit, to do with order of operations. So you know in a two-step pattern rule, multiplication and division, and you know this because of BEDMAS, has to come before addition and subtraction, okay? So remember, this all goes back to BEDMAS and learning that previously, okay? So you know that, and you can highlight that, multiplication, division before addition and subtraction. Okay, so knowing that, we're going to figure out what our pattern rule is. So looking at this, I'm going to just do this in a different color here. Okay, so I'm looking at the pattern rule, or the pattern with the input. So I know it's increasing by 1, okay? Not really useful to us because it's just increasing by 1. So we're probably looking at the pattern rule with the output, okay? So we know it's increasing by 2 each time. Now, the next step here is we're going to take this, and oftentimes whatever the significant number is that it increases by, you're probably going to use that and turn that into the coefficient in the algebraic expression or relation, okay? So now I'm going to take this and go, okay, this is probably the number that I'm multiplying by. Why is it multiplication and not division? Well, think about it again. If the output is significantly bigger than the input in all of these cases, then most likely that first operation will be multiplication and not division. Some examples you'll get, the first operation might be division, but in this case, we know it's multiplication. So we're going to take this and go, okay, 1 times 2. Okay, 1 times 2 equals 2. Okay, how do we get from 2 to 3? We add 1. Okay, so we try the next example. So again, taking that pattern increase of 2 on the output, we're going to use that as our coefficient. So we're going to go 2 times 2 to the input, which gives you 4. Then how do you get from 4 to 5? You add 1. Okay, we can try the next one, but we know this is probably what is going to happen. 3 times 2 again is going to be 6. How do we get from 6 to 7? We add 1. Okay, so we know that the pattern rule, and again, this is from what we did earlier this year or in grade 6, is going to be you're going to multiply by 2 and then you're going to add 1. Okay, so meaning you're multiplying the input by 2 and add 1. So to describe it in words, because you'll often be asked to describe the relationship between the output and the input. So to get the output, you multiply the input by 2, then add 1 to get the output. Actually, that's repetitive. That's enough. So in words, to get the output, you multiply the input by 2, then add 1. This is describing the relationship between the input and the output, because you'll be asked to describe that relationship in some of the questions you'll be dealing with. Now, the algebraic expression or relation now, because we assigned n to the input, so all you're doing is you're taking what you wrote up here and you're turning it into an expression. So it actually ties nicely to what you were dealing with earlier in the unit, where you write a sentence expressing what the algebraic expression means in words. So you multiply the input by 2 to get the output, then you add 1. So we know that the input is assigned as n as our variable. So you're going to multiply the input by 2, so that's 2n, and then you're going to add 1. So that is the algebraic expression or relation for this table of values. So I'm going to jot that in here because that's also how you express the output, okay? I'll just circle that in orange. All right, so that is the algebraic relation, okay? All right, so moving on, we'll do one more example. And this example is where you already have the algebraic expression or relation written out. So please, again, jot down this T table and copy this down. Okay, so our input this time, we'll call it X, because don't be thrown off by different variables that can be used. Because again, the input and the output it's no longer just strictly X and Y. Okay, our output or our algebraic expression for this T table is 4x minus 5. Now, what I would challenge you to do right now is pause the recording, and I want you to write down what 4x minus 5 is in words. And then continue the recording once you've written it down. Okay, so the meaning of this algebraic expression or relation is that you multiply. Now, I forgot to tell you, you should do it in the context of what x is. So you're going to multiply the input, which is x, like the number, by 4, then subtract 5, because that's what that means. Because that's how the input and the output are related, or that's how you get the output from the input. Okay, so our input values this time is going to be 1, 0, 1, 2, 3, and 4. Okay, so we have more values this time. So the question is, what are going to be the corresponding output values? Okay, now if you notice, some of these, you would have predicted already, some of your output values are going to be negative, and that's totally fine. So let's take 0 as an example. And again, if you want to do this on your own, pause the recording and try this out and then just check your answers. I'll do probably the first 3. And then, again, if you want to do them on your own, pause the recording. So if our input is 0, okay, so for 4x minus 5, if our input value is 0, so again, I'm going to show all my work. Because of order of operations, I've substituted 0 for x in brackets. So 0 times 4 is 0, minus 5. So our resulting output is going to be negative 5. Okay. If the next one, if x is 1, okay, 4 times 1 minus 5. Again, I'm substituting in brackets. 4 times 1 is 4 minus 5. That will give me negative 1. Okay, and then I'll do 2, so 4 times 2, oh, sorry, I should have written out the algebraic expression first. So 4x minus 5 equals 4 times 2 minus 5. 4 times 2 is 8 minus 5, and then it's going to be 3, okay? And then you can fill in the rest on your own. So I know that if I did 4 times 3, I'd get 12. 12 minus 5 is 7. And then if I did 4 times 4 is 16. 16 minus 5 would give me 11. So those are my resulting output values. So sometimes you'll be given a T table where you have to fill in the output values based on the algebraic expression already in place. Okay, so that is a review on algebraic expressions or relations with tables of values.